Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time. Here is question 19. A laboratory technician used the function t of m equals 2 times 3 raised to the 2m plus 1 power to model her research. Consider the following expressions. So we have these different expressions and they want us to see which of these functions is equivalent to the one they gave us, t of m. So the only way to do this, it's like a really weird question, is to go into our calculator and plug each in and check the coordinate points. So if we plug in the first one, so we're going to plug this into y1, so we'll keep track of each one. This is going to be y1, so we have 2 times 3 raised to 2, so we're going to use x instead of n, plus 1. So when we go second table, we could see we get all these values. We have like 1.1e minus 5 and 1e minus 4. So, okay, so we're going to go one by one looking at each of these functions and seeing if they have the same coordinate points or not. So this, we're going to put this in as y2. So let's see if 6 times 3 raised to 2x. Let's go now to the second table and see if these match, if the coordinates match. So you'll notice that they do, this crazy 1.1e to the negative 5 there, both in y1 and y2. So we know that 1 is going to be included in the solution, Roman numeral 1. So let's see if this matches the third y. Let's put this as y3. So let's look at this one now. 6 times 6 raised to 2, let me put this in parentheses, 2x, second table. So let's see if this matches. So we have y1, y2, and now we got to scroll over to y3. So notice these coordinate points do not match. These look totally different. 1.1e to the negative 5, that's what we're looking for, and then y3 has 2.8e negative 9. So we know that this is not an answer. So now let's, so I'm going to erase this one because that's not one of the coordinate points we want to be comparing. And we're going to label this y3, so we just keep track. So, because that's what we're putting in for in the calculator. So we have 6 times 9 raised to the x. So let's see if this matches our coordinates. So this is y3, and notice this matches. And this is also included in the solution. So we need Roman numerals 1 and 3. So the only answer that has that is choice 3. So now let's look at question 20. Which system of equations has the same solutions as the system below? So this is kind of an annoying question because even if you like and are good at solving systems equations, now you have to like find the answer to like 5 until you find the right thing. So let's first find the main one that we want it to be matching. So we want to find the answers to this. I'm going to do this step by step by using elimination. So that's just one of the methods. So let's write this out. 3x minus y equals 7 and 2x plus 3y equals 12. So with elimination, the goal of elimination is to add the two equations together and cancel out one of the variables. So you could see that, so 3x plus 2x is 5x, so it doesn't cancel out. So nothing cancels out yet, but notice if we multiply 3 times this entire first top equation, we now get, so let's bring this down, distributing this, 3 to each term, so we get 9x minus 3y equals 21. And then this bottom equation is just going to stay the same, 2x plus 3y equals 12. So I also have a video on how to solve simultaneous equations if you want to check that out. So now we're going to add these together. 9x plus 2x, 9 times 11x. And then these 3 minus 3y plus 3y, that's when they cancel out, when they're opposites like that. And 21 plus 12, this just gives us 33. So we could divide both sides by 11 and get x equals 3. So now we found x, but we also have to find y. So we're going to take x and plug it back into one of our equations. So right away you can see 3x minus y equals 7. That looks like the easiest equation to work with, so let's take that one. So we have 3x, but remember we found x, it's 3, so we're just going to plug that in. Minus y equals 7. This gives us 9 minus y equals 7. And when you do a little switcheroo here, we'll get 9 minus 7 equals y, which is 2 equals y. So we solved the original equation. So we're looking, so x equals 3, y equals 2. And now we're looking for something that has that. One of these choices will have the same answers. So the only way to do this, unfortunately, is to try each choice step. Let's look at choice 1, where we have 6x minus 2y equals 14, and minus 6x plus 9y equals 36. So right away, you could see the 6's cancel out, so this one's kind of nice to work with. And then we have 9 minus 2, which gives us 7y equals 3, or equals 50. So right away, 7, you could see that 50 divided by 7 is not going to be equal to 2. So we know that choice 1 is not the answer. So let's try choice 2. So choice 2 says 18x minus 6y equals 42. 4x plus 6y equals 24. So if we add these together, 18, 19, 20, 21, 22, so this will give us 22x. These cancel out, and we're left with 66. So when we divide both sides by 22 to get x alone, we're going to get x equals 3. So okay, that's looking good, because that's what we need. But let's make sure we also have that y equals 2. So we'll plug this back in to the second equation. 4 now times 3 plus 6y equals 24. This is 12 plus 6y equals 24. Subtract 12 from both sides, and we get 6y equals 12. Divide the 6 out, and we get y equals 2. So this was the answer we're looking for, right? We have x equals 3 and y equals 2, just like this equation right here. So choice 2 is the answer. And if you want to see in more detail how to solve this, check out the simultaneous equation video. See step by step the different ways to solve these. So question number 21. A population of paramecia p can be modeled using the exponential function p of t equals 3 times 2 to the t, where t is the number of days. So let's just underline that. T is the number of days since the population was first observed. Which domain? So domain, remember, is always the x values, or in this case it would be the t values. The t values, which is the number of days. Which domain is most appropriate to use to determine the population over the course of the first 2 weeks? So if you think about the first 2 weeks, we want to know about the first 14 days, because there's 7 days in each week, right? So we want to know the values between starting at 0 and up to 14. So with inequality notation, the only one that fits is choice 4, because when the inequalities are both less than or equal to, less than or equal, this really means like between and including 0 to 14. So that's just kind of a translation of what this means. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!